Hi everyone, welcome back to my channel. Today, we'll walk through the most important DICOM tags used in RTSTRUCT files. Understanding these few tags will help you quickly debug contour import issues and build reliable DICOM-based tools. Let's get started. What is RTSTRUCT? RTSTRUCT is a DICOM structure set. It stores region of interest definitions and contour geometry used in radiation therapy. RTSTRUCT is used by treatment planning systems and oncology information systems. It's important to know that RTSTRUCT contains no dose data and no beam data, only structure definitions. On the high level, RTSTRUCT data is organized in a hierarchy. At the top level is the structure set ROI sequence. Each ROI is then linked to an ROI contour sequence. Inside that, contours are stored slice by slice in the contour sequence. Understanding this hierarchy is essential because most RTSTRUCT issues come from confusion between ROI level and contour level data. Now let's look at examples. The structure set ROI sequence is defined in the DICOM tag 30060020, as shown here. Each ROI has an ROI number, an ROI name, and an optional ROI generation algorithm, as shown here. And inside the structure set ROI sequence, it defines each ROI. And here is example of one ROI item. Next, ROI Contour Sequence. This is stored in 30060039. And again, under this tag, each item represents as one ROI. And they are all linked together by the ROI number. And finally, the contour sequence, which is the critical text, stores the actual geometry of the ROI contour. This is defined in 30060040, as shown here. And underneath it, on each item, represent the contour data of one image slice. As you can see here, the contour data 30060050 define the XYZ coordinate of each point. And you can see here, under each item, the Z coordinate is the same because it represents all the contour points in one image slice. And here, the reference SOP class UID, this represents CT image, and the SOP instance UID represents the specific image slice. And you can see it changes for each item under the contour sequence. Another thing to point out is the contour geometry type, and the closed planar is the most common for the closed contours. It can also have type of point if the structure set represents a point geometry. So to summarize, by understanding just a few RTSTRUCT DICOM tags, you can debug most contour import issues very quickly. Knowing where contours live, how they are linked, and how slice-based geometry is stored makes DICOM far less mysterious. This knowledge is essential for automation, QA tools, and TPS-independent workflows. Thank you for watching, and I'll see you in the next video.